We've spent this series building the harness around the model: context, memory, tools, verification, safety, observability, and governance. Now we need to answer the production question that determines whether those components actually work together. I'm Mehrdad, and this video is about evaluating multi-agent systems. The central reframe is simple. A multi-agent run isn't merely an answer we can grade, it's a path through agents, tools, and decisions, so we have to grade the path. Here's the uncomfortable starting point. A multi-agent system can pass every test you wrote and still be failing in production. Most tests inspect the final answer, while the route producing that answer remains invisible. The answer may be correct even when agents run out of order, a recovery loop burns budget, or behavior changes between runs. Grade only the output, and those problems all look green. Yet that hidden route is exactly where reliability, latency, and cost begin to break. A single model application usually gives us one output to score, but a multi-agent system makes many choices before producing one. It selects agents and tools, determines their order, moves context between them, and decides when to retry or stop. The same request can therefore reach the same answer through very different routes. So correctness is necessary, but it isn't enough. We also ask whether the system used the right roles, followed a healthy sequence, recovered appropriately, and spent a reasonable amount. To evaluate that route, start with 4 distinct failure modes, because ordinary monitoring reliably catches only the first. A hard failure is loud. The system crashes, throws an exception, or returns an explicit error. Fragile success looks correct, but only because an unplanned agent or recovery loop happened to rescue the run. Behavioral drift means equivalent requests take different paths, produce different depth, or consume different time while every final answer still passes. Silent degradation appears gradually as calls, steps, latency, and cost rise from one release to the next without an error. If dashboards watch only crashes, they miss 3 of the 4 ways this system gets worse. This video condenses the map, while the full evaluation series develops each mode in depth. The next trap is reporting one blended success rate because different agent roles perform different jobs and need different measures. Orchestration directs the work and appears in nearly every run, so its raw failure rate tells us little by itself. Planning needs structural checks, whether the steps are valid, complete, ordered correctly, and grounded in the task. Support agents gather context and data, which often makes them the upstream source of a task agent's visible failure. Task agents perform the hands-on work, so success rate, quality, and speed apply more naturally there. Score each role against its responsibility, then combine those signals only after preserving what they mean. Role-aware scores still don't identify root cause, because errors spread downstream through dependencies between agents. The agent showing the most failures is often the victim receiving bad context, stale state, or a timeout from upstream. Imagine hardening Agent X for an entire sprint because its errors dominate the dashboard, yet the same failures continue. The trace reveals that Agent Y timed out earlier and handed X incomplete data. Fix Y, and X recovers without another patch. Replace the question who failed with what started the chain, then follow the damage forward from that origin. 2 important failures produce no exception at all: inconsistent behavior and loops that make no progress. For consistency, group requests that mean the same thing, then compare their outputs, paths, tool choices, and runtime. One difference may be harmless variation, but several moving together can reveal real behavioral drift. Loops have an even clearer signature. Valid-looking steps repeat while tokens and time increase without meaningful state change. That shape can be detected with fixed rules over repeated actions, observations, or state transitions. We don't need a language model judge when deterministic structure already exposes the failure. Recent evaluation work sharpens the same principle. The system, not the isolated model, is the unit we actually ship. Topology, orchestration logic, context flow, and error handling can change results even when the underlying model stays fixed. That means we evaluate the deployed configuration instead of assuming a model benchmark predicts system behavior. Attribution also needs full execution traces, including inputs, context, intermediate decisions, and replayable runs, rather than output logs alone. Those traces improve step-level diagnosis, but attribution remains genuinely difficult because several causes may plausibly contribute to one failure. Instrument the route so evidence is available, rather than expecting an evaluator to reconstruct missing history. We still need a summary that stakeholders can read, so build one health score without flattening away the diagnostic detail. An executive sees the top-level figure composed from a small set of independent pillars. An engineering lead sees those pillars: reliability, planning quality, behavioral consistency, and anomalies across traces. The engineer debugging a regression sees the underlying per role and per step metrics behind each pillar. The layers represent the same evidence at different resolutions. Each pillar must also be able to fail independently, or averaging will hide the exact weakness the score should reveal. This gives us the through line. When we evaluate the path, we're really evaluating the harness around the model. The model supplies reasoning and answers, while the harness chooses who runs, what they receive, how they recover, and when they stop. Reliability lives in those decisions, not only in the final text. Path evaluation isn't extra reporting around the system, it's how we measure whether the harness itself is doing its job. Carry 3 ideas into your evaluation design. First, score the path as well as the output, because ordinary logs expose hard failures while fragile success, drift, and degradation remain hidden. Second, match metrics to each role and trace failures back to the origin rather than blaming the downstream agent showing symptoms. Third, evaluate the deployed system on full traces, then roll that evidence into one layered health score that every audience can inspect. Grade the path, because that's where the harness reveals whether it is reliable. If this series is useful, subscribe to Multi-Agent Academy, and you can also connect with me on LinkedIn. Next is video 17, The Cost of Harnessing. We'll examine how retries, verifier passes, parallel agents, and longer traces buy reliability with tokens, latency, and steps. Cost belongs beside quality as a first-class signal, not as a surprise on the bill. I'll see you there.